Welcome to my channel, and today I'm going to explain the dendrites that are formed in a pure metal. Pure metal stands for there is no any alloying element, no alloy should be present, like pure iron, pure aluminium. These are the pure. There is no any alloying element further added. So let us start. This is the diagram which is taken from Red Hill book. Red Hill physical metallurgy book, and I refer to all the diagram that I select in this presentation is from Red Hill book. So this is the temperature curve where you can see there is a solid and there is a liquid, and there is a equilibrium freezing temperature. You can see this is the interface. This is what this is the interface. This is what this is interface. After interface, the liquid temperature is decreasing, and before interface there is a solid temperature decreasing. This is the phenomenon, and at some point of time at the interface the temperature is maximum. So what is the importance of this diagram? Basically, the solidification start from this interface, where liquid, after interface liquid temperature decreasing, but here the solid temperature is very high. So suppose that this is our interface, so at the interface the temperature is very high. So in the same time the liquid temperature, we're talking about this is the interface, but at the liquid temperature going to be decreased. So we can say that at this interface where here is the solid, in this region there is a liquid. At this interface there is a small driving force to nucleate these arms. These all are indicated at the small arms in growth in this direction. Keep in mind that at the interface there is a very small driving force. Because why the small driving force? Because there is a degree of supercooling is very small. Degree of supercooling is very small, and also at the same time this equilibrium freezing temperature also dominated. So both degree of supercooling is small and this freezing temperature is dominated. That's why the nucleation rate at this interface is very small, but somehow the arms is nucleated at this interface. Moving to the next thing, if the arm is nucleated, suppose that this arm is nucleated, this is the interface, and this is arm, both in direction, but between two arms there is a liquid. And this is the solid. Suppose that if we're talking about the temperature at this point, the temperature is suppose that TA, and in the liquid region temperature is TB, and is always suppose that TA is always greater than TB, because at the solid the temperature is extracted from this liquid region, so that TA is always greater than TB. And this condition, what happen? In this condition, what happen? If the temperature is higher, TA is higher than TB, there is a temperature gradient in this direction. In this temperature, in this direction, and due to this temperature gradient, TD upon Tx, in this direction, there is also one arm is going to be nucleated. This is known as primary. This is known as secondary. Let me draw once again. This is our primary arm. This is the secondary. This is the interface. This arm is also generated due to the temperature gradient in this direction. Otherwise, it is very impossible in the case of pure metal. Another thing is, if we're talking about compared to this region and that region, suppose the temperature at that point and that point, suppose the temperature is TA at that point and TB in that point. This is the liquid region. Here temperature A is always greater than temperature B. So due to temperature gradient, another arm is also generated in this direction. So let us draw. This is our primary, this is secondary, and this is suppose the tertiary. So we can say that in the primary, this is the secondary arm, as I explained. We can say that in the pure metal, dendrites form due to temperature gradient, and the temperature gradient should be less negative. Otherwise, it is impossible to say that. Suppose that this is our solid, this is our liquid, this is the interface. If this interface is moving in this direction, I suppose the temperature, T temperature is here, and temperature profile is decreasing. So we clearly say that temperature gradient del x del dt upon del x is less than 0. In this way, we get this type of three-dimensional structure. This is known as dendritic. It is a tree-like structure where this is the primary arms, this is the secondary, and this is the ternary. So, in the concluding remark, conclusion is what dendrites is formed first if temperature gradient is less than 0. In which case? In the pure metal. This is the condition where our dendrites is formed. Thank you very much.